ladies and gentlemen, we are at the 5th lesson in Chapter 7. This is proportions in similar triangles. So we're going to take a look at what sort of these equal ratios we find in similar triangles. And so we're going to use what's called the triangle proportionality theorem, and then its converse. Alright, so the vocabulary that we have is just mid-segment. So the mid-segment of a triangle. And it's the segment that connects the midpoints of two sides of a triangle. And so if we draw a triangle, the midpoint is the middle of the side, which means we create two congruent segments. And if I take the midpoint of this side and create two new congruent segments, the ones in red aren't congruent to the ones in green. It just means green and green is congruent to itself, and then red and red are congruent. So the mid-segment is then the segment that is created when we connect those. So this is the mid-segment. So what happens when we draw on that mid-segment is we create overlapping triangles. So obviously from the work that we've done already, we're going to start to see some connections in these new similar triangles. So what is that theorem, 7.4? It's the triangle proportionality theorem. So it says if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. Alright, so we know one of our lines is parallel to a side of a triangle. So here's the line that we have parallel to the side of our triangle, QS, and it intersects the two sides. We're intersecting at T and we're intersecting at U. Then it divides the two sides proportionally. So what that means is that if TU is parallel to QS, which we saw, then RT, the ratio to TQ, is going to equal RU, that proportion, or that ratio, to US. So it takes top to bottom, those segments. Okay, we're not talking about the entire sides anymore. Now we're just looking at the two segments that are created. So let's try and use that. We want to find the value of that. If you notice, we have what we need. We have these parallel sides, or these parallel segments, I should say. All right, and we have these intersection points. Notice we're only dealing with measurements on the sides that are intersected. There's no measurements on the third side of that triangle. So I can set up my ratios. So we have CD to DB is going to be equal to CE to EA, top to bottom. And so that's the ratio that we're setting up when we talk about this triangle proportionality theorem. We're doing top to bottom. And these are segments, not sides. So now we're going to substitute in the values that we have. So CD is 4, DB is 8, and that equals X over 12. We're going to use that cross product property, which means we're going to do 4 times 12 is equal to 8 times X, do your multiplication, so we have 48, is equal to 8X, and then you divide each side by 8. So we get X is equal to 6. Now some of you looked at it and said, I know it should be 6. 4 is half of 8, and 6 is half of 12. You're seeing those ratios. Awesome. What this cross product does is it allows you a way to verify that. But yep, using your mental math, seeing that relationship allows you to also deduce that X is equal to 6. All right, so let's take a look at what we have in example 2. We're finding the segment lengths. All right, so we know we want to find the value of Y. We're finding another segment. That if PS, the entire segment is 20, so the entire segment is 20, and that just the top segment is Y, we know that the bottom segment here is going to be the whole minus the part. So this is where they get this 20 minus Y. So we're probably going to have to use some algebra. What you're going to see here is that to name these segments or to name sides, we're going to have to do some of this addition and subtraction of the segment addition property. But let's take a look what we have. We're going to set up the same way. Set up those ratios. PQ to QR is going to equal PT over TS. Substitute in the values that we have. And so PQ is 3. And we know that QR is 9. We know that PT is labeled with Y. And TS is 20 minus Y. Now this one isn't necessarily going to be one that we can solve using mental math because we don't have any measurements for segments on the PS side. We have to go through and do our cross products. So we're going to do 3 times 20 minus Y, and that equals 9 times Y. We need to distribute, so we do 3 times 20 is 60, and 3 times Y is minus 3Y, and then 9 times Y is Y. I have 2 variables in this problem, one on each side of the equation, so I'm going to add 3Y. I'm going to undo this minus 3Y by adding 3Y, and so that's going to give me 60 is equal to 12Y. And then I need to divide each side by 12, and I get Y is equal to 5. So what I want to do here is move on to the follow-up. We're going to do this follow-up together in a split screen because by doing what the follow-up is asking us to do, it allows us to track, to verify our answers. They want to know how long is TS. Well, what we just found out is that PT is 5. And so if the entire segment, if the entire side is 20, we said this remainder had to be 20 minus Y. So 20 minus 5 is 15. So TS is that 20 minus Y. So TS is equal to 15. So I want to take a look at what you have here. I'm going to draw this triangle in over here because I feel like we've got a lot of marks over there. There are parallel lines in. RQP, TS. We said that this is 3. We said this is 9. So this is 3 more. 9 is 3 times 3. We said this was 5, and we said this was 15. Does that follow the same scale factor, the same relationship? Well, yeah. 15 times 3 is 5. So what we're seeing is that by using these cross products, by taking the whole segment, or the whole side and minusing that segment, we're able to get an answer for Y that fits with what we saw in the 3 to 9 side. All right, so now we have 7, 5. Now we have this converse. So what we're going to do is if I can find equal ratios, then we're going to say that the segments are parallel. So in words, what this means is if a line divides 2 sides of the triangle proportionally, then it is parallel to the third side. And so what that means here is that if RT to TQ is equal to RU over US, then we know that TU, this segment, will be parallel to QS, this third side of the triangle. So let's take a look at how we can use that. So now what we're going to do is determine if we have parallel lines. We're determining what things are parallel. To know if they're parallel, you want to show me that you have equal ratios. So we need to find and simplify those ratios that we have here. So if we take a look at this, we're going to take a look at LM and put that in a ratio over MG, so top to bottom. So the top segment over the bottom segment. 56 over 21, I see that those are both divisible by 7. So we divide each of them by 7. We get 8/3, and nothing divides into 8/3, so that's our simplified ratio. If we take a look at the next side, we have ln, and we're going to compare that to NH. So we're going to write a ratio with that. ln is 48, and NH is 16. When I look at 48 over 16, I know they're both divisible by 8, but if I look even farther, they're both divisible by 16. So I'm going to divide both of them by 16. And so 48 divided by 16 is 1. 16 divided by 16, or 16 divided by 16 is 1. 48 divided by 16 is 3. Sorry, my head gets ahead of my mouth sometimes. So we divide each of that ratios out and simplify that. We get 3 over 1. So what we're looking at is one segment side has 8/3 ratio. The other segment side has a 3-to-1 ratio. So because we know that 8/3 does not equal 3 over 1, we know that MN is not parallel to GH. Okay? So sometimes they talk you through examples where they are parallel. Sometimes they have examples where they're not parallel. So let's go through our checkpoints. I'll do one together, and then you guys will do one on your own. It says find the value of the variable. So when I look at this, I'm trying to find x. So I know x can be put in a ratio with 4. Those are the two segments on the sides. And I want to set that equal to 10 over 5. Now some of you are doing some mental math, seeing some relationships here, and solving for that already. I'm going to go through and finish up the algebra. 4 times 10 is equal to 5 times x. 40 is equal to 5x. So x is equal to 8. You guys are going to do this on your own. But what you need to do is you need to make sure that you look back at example 2. This is the one where they give you the entire segment, the entire side length to start off of 14. So you want to look at example 2 to follow along with. Let's take a look at checkpoint number 3. We're trying to prove that they're parallel, which means I need to look at the ratios. So I'm going to put PR 15 over RT 21, top to bottom. I'm going to simplify that. 3 divides into both of those, and I get 5 over 7. And I take a look at the next one. I have to set up PQ, that's the other side of 17, over the bottom segment of 23. 17 and 23 are what I consider to be nice numbers for ratios because they're prime, so they don't simplify. So because 5/7 and 17 over 23 are not the same, 5/7 does not equal 17 over 23. They are not parallel. Okay, RQ. Let's see if I can move that around. I would say RQ, the segment here in the middle, is not parallel to the third side, GX. You guys are going to do this one on your own. Don't be afraid to get a yes answer. Just so happens that we did 2 that were not parallel. This one could be parallel. All right. Now we have what's called the mid-segment theorem. It says that the segment connecting the midpoints of 2 sides of a triangle is parallel to the third side and is half as long. All right, we're always going to have that relationship. So when we're looking at now the entire side, not just segments, we're looking at a full length. So what this means in words, if we're looking at triangle ABC, if CD is equal to DA, so we have this mid-segment, and we have CE is equal to EB, making this a mid-segment, and we know that DE is parallel to AB. We need those 3 things. Then we know that DE is equal to 1/2 of AB. We're going to take half of that third side of the triangle. All right, so what is the relationship between theorem 7.4 and 7.6? Well, 7.4 talks about the sides being proportional to each other when we look at the intersecting sides. So 7.4 is the intersecting sides relationship. What happens to those? 7.6 is the ratio of the mid-segment. Which is always a ratio, I don't want to close mine, it's always equal to 1/2. That ratio will always be 1/2. So 7.4 is having us look at the sides and looking at those ratios. 7.6 is telling us that the mid-segment will always have a ratio of 1/2 to that third side. All right, so how do we use that? They want us to find the length of QS. In the diagram, we know that S is the midpoint and Q is a midpoint because of our congruency marks. Okay, S is the midpoint of RT, and Q is the midpoint of RP. So QS is what we would call a midsegment of triangle PRT. So if we have the midsegment, then QS is equal to, so we're going back, we're trying to find this QS. QS is equal to 1/2 of its parallel side, the third side, PT, the side it doesn't intersect, which means we're going to take 1/2 times 10, which is 5. So the length of QS is 5 units. All right, so we have 2 checkpoints. We'll do number 5 together. You're looking for congruent sides, so we know we have congruency here, and we have congruency on the other side, the intersection. So we know P is a mid-segment. All right? So P is the mid-segment, which equals 1/2 of 16. 1/2 times 16 is equal to 8. So P is equal to 8. You are going to do on your own, and we will discuss in class. Have a great,